X MSA. So today I'm going to share with you how we see OpenCPX MSA going to help with AI scaling. So I think we all heard the end user talking about the challenges, but first of all, optical connectivity now is expected to address a wide range of AI scaling, scale up, scale out, scale across. I won't dive in too much. One of the best opportunity ahead of us is this AI scale up transition from copper to optics. And these came with lots of opportunities and also challenges. First of all, you are seeing 10x more capacity required if you need to address the XPU connectivity for scale up. And then high density is important once you start to get into these very high bandwidth requirements. And low power, you heard Drew talking about that, very critical to drive the picojoule per bit lower. And then high reliability, availability. These are really, really critical as well when we move to very large clusters for training and particular. And then supply resiliency is critical. You don't want to lock in single vendors and face potential hiccups if you have constrained supplies. And the other factor is when we move into these AI deployment, fast time to volume is very critical. Really, not a lot of time for slow RAM in the old days. When the customer want to deploy, they want to deploy in big scale. So this is also new challenges for us. Now moving to the evolution of form factors, this is certainly one of the most important evolution or changes in our industry is moving optical connectivity solutions from the front panel, but increasingly closer to ASIC. So this is represented by the CPO, so-called co-packaged optics. So far, the great benefit or potential for CPO is to lower the copper channel loss between the ASIC and optics. So therefore, you drive much lower power dissipations, but it came with lots of challenges. So just list some of the problems we try to solve here. One is so far, most of the CPOs promoted out there are single vendor lock-in proprietary solutions. And these are very tight integrated with ASIC. And also came with it is compounding yield challenges when you try to have a really tight integration with ASIC and practically on the co-package level. And also lacking technology diversity. If you really pin down to particular proprietary technology, usually they pin down to a particular choice of implementations. And if you're looking at the reliability, some of these newer type of technologies, they really do not have lots of field data or deployment history. So this is kind of challenges. How do you then actually recognize the very low fit kind of reliability required by AI scale up? And then once you lock in to a tight integration, usually they came with poor serviceability. Basically, they are so tight. Usually you have to eliminate the whole package, very expensive package if you integrate it with ASIC. And then also when we try to move optics closer to integrate ASIC, you kind of eliminate the choice of copper if the integration is that tight. Then also mass production deployment track record, if you come in with this newer technology, it's come with a risk as well. And we talk about supply resiliency, challenges we have. So there, as Dan pointed out, there's a few open optics connectivity solutions announced right at OFC time. And I particularly point out two of the MSAs we are intimately familiar and actually participated in. One SPO MSA. Sunil is going to really talk about this part. And I will really talking about OpenCPX MSA. This is really mission is an open socket CPO MPO for economical large scale AI deployment. So this is our mission for the OpenCPX MSA. And I just open up the member list here. We basically have 6 founders representing a fairly large market share already with the optical connectivity solution, but now we have new members just now joining. And I listed a few just recently joined as contributors, and we actually have 80 plus companies now start to join in. So we're going to have really a very broad and very versatile ecosystem represented by, I would say, majority of the optical connectivity industry. And these are including component side, connector suppliers, ICs and ASIC suppliers, and system integrators. So hopefully this is going to build up really healthy ecosystem to support open CPO, open NPOs. And here, just addressing the pain points we pointed out. To address the single vendor locking, certainly that's MSA purpose is to enable a multi-vendor, multi-source conditions for the ecosystem. And we also, with the socket approach, we basically enabling a decoupling with ASIC and supporting NPO, CPO, IOA. I'll explain what IOA is, but there are basically a wide range of deployment scenarios available now with this open socket. And because of this decoupling, we also addressing the EO problem because you don't have to address at the final assembly level. You can individually test these connectorized engines before installation, so you can actually really address this compounding EO problem. And then within the form factor, certainly we are open, like earlier, talk about available technology choices. We're going to start with the DR optics, but certainly we are actually supporting multiple capabilities within the form factor, including OCI. I'll talk about that later. Reliability, because of this openness, we can basically allow a healthy field-proven, reliable silicon photonic deployed, don't have to lock into a particular newer bleeding edge technology. This actually allows those mature capability to be deployed. And then serviceability, because it's a pluggable socket. So this really allow economical repairing, replacement, and much easier serviceability. And because the socket, we actually define socket can support both optics and copper. Elaborate a little bit more there. This allows, again, flexibility deployment for different scenarios. And then mass production deployability. This is really, like we discussed earlier, you now, because you open up the socket, you can actually put in different silicon photonics with field-proven lasers and packaging, etc. So that really allowed that maturity to continue or leverage from largely deployed in a pluggable form factor now into the NPO CPO environment. And obviously, supply resiliency going to be significantly improved. Now you have so many of the companies already involved in the optical connectivity business, they can continue to leverage on this open ecosystem. Here, just share with you what the open CPX form factors. So we already defined these four combinations. On the left upper corner, this is so-called type 1 connector, basically involves a separate RF connector from a I2C power connector. So this way you can actually have flexible either single plane or even multi-plane connectivity enabled. And we also offer the external laser version and also the integrated laser version. So again, within the form factor, you can deploy these different options. Then there's a second row is a type 2 connector. Basically, these are more of a purpose-built connectors. You can basically allow you to integrate both RF and power I2C in one connector system. So this way, you basically have a simpler connecting system for both the external laser and internal laser version. Here again, just to show you diversity and rich combination of deployment scenarios. From the left side, you can see you can deploy NPO for XPU scale up, meaning ASIC. You can place this engine right next to your ASIC. It can be sitting on a PCB very close to the ASIC. Then migration over, you can actually go to also a very high density switching environment. You can place them either on the PCB itself, or you can place onto the substrate if the, for example, the ASIC substrate are willing to be opened up. Then this socketed approach can directly address a CPO deployment scenario. The last one on the right side, we're calling this IOA, integrated optical attachment. this is actually interesting scenario where you can actually have a very low loss, high HDI kind of high performance board directly attached to the ASIC substrate, but then as an extension, you can attach either copper or optics on it. So you see IOA or ICA in this scenario that allow you, again, another hybrid version where it's sort of bridging between NPO and CPO, but allow you to have a low loss connectivity between ASIC and optics. Then you can also enable the mix of copper and optics. I think there's a famous saying there, use copper when you can and use optics when you must. So this actually fit that scenario quite well. Basically, you have a socket where you can either deploy copper or deploy optics when you design your system that allow that flexibility of combinations. And you can actually also enable, in this case, a mixed optical mix. For example, in this example, I think Sunil is going to talk about SPO. For example, this is actually a mix of MPO, CPO, or XPO deployment. In this scenario, you have half of the switch facing down and half of the switch ports facing up for scale across, but then facing down version going to the scale out domain. So this is give you a rich combination of deployment. Give you an example of OpenCPX MSA. This is a TeraHop Diablo 1 6.4 optical engine. It's a type 1 connector with integrated laser source and already have the silicon photonics with very low fit demonstrated in the field. So you can actually deploy these optics already proven in the field and in the different form factor as a OpenCPX optical engine. And here's just our part to demonstrate our field deployment data with these silicon photonics already deployed over 25 million in a transceiver platform, but we can carry forward with these silicon photonics into the CPO-MPO environment. Just to highlight that not silicon photonics, there are lots of silicon photonic varieties, but certainly our version has been proven in the field and demonstrated very low fit, in this case, already well below 0.1. So customer going to feel comfortable deploy this kind of optics because it's already have a proven field deployment data to back up with a very high reliability. This is a scenario looking at Arista recently built a switch, actually using our OpenCPX engine. And you can see with the integrated laser, it looking really clean. Basically, surrounding the pink portion, this is the ASIC 100T switch in the middle, and then surrounded by 16 of the MPOs. You can call it CPO or MPO, depends on how you do it, but this is an IOA example. So with a pigtail, you actually eliminate this potentially failure-prone optical interface because now you can basically just pigtail all the way to the front panel. There's no contaminations, concerns during the installations. There's no external EO SFPs with the PM fiber and coming in with a pretty complicated fiber harness. So the whole thing is really, really clean. And then you can see we have separate cooling cold plate for ASIC or for the CPX optical engine. And this is just an early demonstration concept, and then real system certainly is in the pipeline. You see multiple system vendors now working with these kind of capabilities. My last page is looking at the OpenCPX MSA potential roadmaps. We are basically focusing on the first generation, Gen 1, 6.4T for DR8. This is in the work and it's coming out spec release coming up forecasted by before ECOC time. And then we are looking at the next couple of generations to see what's potential to further enhance the OpenCPX. One of the low-hanging fruit is to expand from 6.4T to 12.8T with more lanes. Or we can start to support the OCI, as Drew pointed out. OCI is a PMD. Certainly, we are capable of supporting OCI with the proper electronic design to go with it and supporting OCI PMDs